Hi guys and girls, welcome to the video today. Thank you very much for joining me, and I do hope you're well out there wherever you are watching from. Thank you to all my regular subscribers and YouTube viewers on the channel. Great to have you with us again today on the video, and if you haven't liked and subscribed already, be thinking about doing that. Anyway, today's video is another update on the update, as per usual with my model railway. I'm getting through a construction phase at the moment. I'm just finding new things to do with it. And I'm focusing more on the electrical side of things rather than the actual add-in to scenery at the moment. Because this is something that's important. If you don't get the control side of your layout right, whether it's analog or DCC, you'll have problems. But if you keep it as reasonably simple, but also very functional, you'll have hours of reliability. And also the things that you need to do will work. So I'm not going to dwell on this area too much, because if you want to know about why I'm putting this here, scoot back to the last video upload and you'll catch that. But basically this is going to be where a lever frame is going to sit on here for the future. I've put these switches in, as I mentioned in the last video. So what have I been doing today? Why am I doing this video for you? Well, hopefully, again, this is going to give you a few little brain teasers and some tips on what you can do at home in your own setup. Maybe some ideas. You don't have to copy exactly what I've done, but if it gives you an idea of how to do things, then box is ticked and job done. That's what I say. So I've got my switches mounted here, and as quickly an overview, these are going to be for our building lights. The top ones are going to be for our street lighting. These are more of what I call retro switches, and I do like these. I just prefer these type of switches. They look nice. So what have I been doing today? Well, if I lift these out, like so, I've now hardwired these all in. So we've got just 2 tags to solder up there, which has been done. We've got a red and a green wire, color coded, if preferable, which I always try and color code things. Can't always do it because I don't have the amount of wire sometimes, but if I can, I'm doing sort of medium to small jobs, I'll always color code stuff to make it easier for me to understand and remember what goes where. So those go back, pop in there like that. And these are individual switches. So we've got building light, building light, building light. The end switch, I know exactly what's for, even though it's wired up. I know exactly what this will do. I don't think I've even wired it up, have I? And the answer to that question is no, I haven't. That's right, good. I remembered not to wire it up, because this is going to be a separate wiring job. Just simple 2 wires. It won't need a power feed because it's an isolation for a track section, which I showed you in the last video. This is the switch for it. So it will enable me to isolate a section of track in the steam loco depot to have 2 trains standing on one piece of track. Flick of the switch and one will move and one will not. And I flick it back the other way, and then they'll obviously both sections will be energized. Anyway, this is the exciting bit I'm dying to show you guys. Okay, so over here we've got an in and an output side, both 16 volts with both pairs of red wires. Now then, this is what you call in the engineering world, in terms of electronics and electrical high voltage stuff, this is a bus bar which I've designed myself this morning. And the job of a bus bar, basically, things like a big substation, big electrical substation where the power comes in off the national grid and it gets fed all through the system. When it comes in to a substation, you have what's called a bus bar, and the bus bar's job is the following. As you can see, for example, on the red cables there, we've got the red wire soldered onto one bus bar, and then the green cables are soldered onto the opposite bus bar. 2 pieces of off-cut wood, one there and one there, and then a couple of screws drilled and screwed into the wood, and then soldered the cable on top. And what did I use for the material? Well, obviously you can't use something that doesn't conduct electricity. It has to be very good conductive material. Ideally, I would have loved to have used brass or copper, but unfortunately I don't have that material. But what I did have was this stuff, guys. You might have used this in your home. This, where I live, we've got a large car park downstairs, and just off the camera there's these big giant industrial sized recycling bins that you put card and glass and paper and bits of stuff in there, plastic. Somebody a couple of months ago threw this brand new, as you can see, it was sealed in the packet. I've opened it today for obvious purposes to use it on this, but this was sealed up. It wasn't even opened, it was brand new. And this is basically the stuff that you use to hang curtain tracks on and curtain rails and curtain poles. It's very, very strong cable, like a steel cable. Great for doing modelling jobs if you're building like a shipyard or something industrial that requires a really nice steel cable. You can wind it around a drum, or you can do lots of this modelling wise, scale wise, but because its conductivity is 100%, this is what I use the material for this bus bar system. Quite simply cut into 2 strips or 2 lengths, and then I just soldered them to the top of those screw heads there, so they're in place, a negative and a positive bus bar system. So in theory I can solder and connect up in the future any circuit, as long as basically you put the posi legs on one side of the bus bar, and then the opposite feed of the bus bar, the negative, you put all the negative legs, as long as they're all soldered together. And the idea of a bus bar basically is the follows. It allows you to connect multiple legs of a circuit which are all the same polarity on one strip. So it saves you basically bunching the wires up and trying to feed them into one small little socket. If you can imagine that our model railway controller, basically I've got this little diagram I drew this morning. It's not perfect, but it's just basically a switch diagram that I was working out. But if we look here, if this represents our model railway transformer, and this particular drawing or doodle is the 16 volt legs coming out the back of your transformer, your 16 volt accessory side. So basically, if you try to squeeze all the wires into 2 little terminal blocks like that, you could do it, but it'd just be a little bit untidy and, in my opinion, a bit messy. So what I've done, I've just basically created this bus bar system so that, again, you can connect or solder one side of all your legs, for example, lighting or any accessories, point motors. You can solder them all to one leg, as long as they've both got a leg each. Obviously, you don't put all the wires on every single wire on one leg of the bus bar. You always put negative side to the negatives, the positive side to the positives. That's so. So again, very simple. They straddle 2 wooden pieces of blockwood and soldered on top there with some screws that side. Coming over here, I've done the same with that. This side's a bit different because I've just obviously got the main feeds soldered to each bus bar wire, and then they come into a terminal block, and then the empty side of the terminal block, the bottom bit which is there will be accordingly a green wire and a red wire that will go directly to the 16 volt side of the transformer there. So that will give that power. So the bus bar will always be live, and whatever's connected to it in that circuit will be powered. In this case, once it goes out through the circuit, it comes back. Obviously it goes back to the switch, and then obviously the flick of a switch, I can control my building lights, turn them on or off, and that's really how that will work. And the same thing will be with these. I'll utilize this bus bar wire again because I've got quite a lot of switches here. Not a lot, guys, but obviously more than one. So what you don't want is a whole bunch of wires being crammed into one little tiny hole on the back of your transformer. Whereas if you've got something like this designed, then you can solder each negative leg and each positive leg accordingly, and it connects them all together. So once they're all electrically connected together, all the posis together, all the neggy wires together, then they will come down into one outlet or input, and that goes into your input side of your transformer, in and out. So that's basically how it works. It's just basically a long layman's term of connecting many wires together on the same circuit, but obviously separately, negative and positive, so that you can have more than one wire going into the same feed rather than having a bunch of wires going into one separate hole, as it were. If you go on YouTube, Obviously, because as a member of the public, you can never go into a substation because it's a silly and dangerous thing to do, and you will die, and also you'll get arrested for trespassing. But the great thing about YouTube is we can find those videos on YouTube, and we can look up, and you can have a literally look for yourself how it actually works on a high voltage principle. As for me, I've got a lot of high voltage experience. I used to work on the 25 kV overhead line system in Great Britain. I was an overhead lineman, so I used to deal with 25 kV, switching out, installing wires on the overhead catenary, changing insulator pots, changing bonds, anything to do with the overhead line structure. I did that for about 3.5 4 years. So it did give me a little bit of an idea about how circuits work and stuff like that, the principle. Anyway, this video today isn't aimed at the electrically minded genius. So again, this is something that anybody can do at home. You don't have to do it the way I've done it, but the principle is the same. Get yourself a piece of conductive wire. You don't have to use something stiff like this piece of steel cable. If you've got a piece of brass or a piece of copper, even better. Or failing that, you can just use a piece of model railway wire and just take the sheathing off, or you can cut it at intervals where the wire is going to be soldered onto, and you can tag it accordingly along the wire. You can do it that way. I've just put mine neatly suspended between these two blocks of wood, purely for neatness, and so it's easier to connect things up and to see where things go. And also, I think it looks cool. My own substation. So yeah, that's what I've been doing today, guys. About 12.5 minute long video, I know, today, but just plenty of time to digest really and see what I've been doing. And I hope again this inspires anyone out there to have a go at doing this yourself, because you will find definitely as your railway expands, whether you've got a massive layout in the loft or you're starting out in the hobby, maybe you got a train set for your birthday or Christmas last year or something like that, and you want to make it more permanent on the baseboard, and you've got to the baseboard stage, and now you want to start adding things like point motors and lights and lots of accessories. This is a very simple but effective way to connect up all those accessories without having to put too many wires, having it really simple, just 2 wires going into your 16 volt power side and having them all connected up thus so. Anyway, I know it looks complicated, it does look technical, it can look very bewildering, all this wire and things going everywhere, and if you're not electrically minded, it can be quite daunting. But to be honest with you guys, apart from my training that I had when I worked on the railway 19 years ago, I've always been fascinated by how things work, and I've always made loads of mistakes wiring and connecting things up. It's the only way you learn. Obviously, you don't play with mains voltage, but in terms of the 12 volt DC and 16 volt AC in the world of model railways, you just experiment. Obviously, if you've got a diagram to follow, you can follow it. If you're not sure, you can ask a grown-up, you can ask someone to help you. But for the general purpose of this video, this is my designed bus bar system that I have made and installed today. Anyway, that's that. I did tell a fib because it's almost 14 minutes long now, this video. So it's time for me to go and grab a coffee, and hopefully you'll do the same. Have a lovely day wherever you are, and I'll see you in the next video. All the best and take care. Don't forget to hit the like and subscribe.